Good morning children. Today we are going to learn meter bridge experiment. In meter bridge, there are two experiments are there. First one is we are going to find out the unknown resistance. Meter bridge first experiment to determine the unknown resistance. Second part of the experiment is series combination is there and then parallel combination is there. First we will go to the one by one. So here you see that in meter bridge experiment, what is the aim of the experiment is to determine the resistance of a given wire by using meter bridge and to find its specific resistance. Here we will be having two formulas in there. So first thing is what you have to do, you have to find out the resistance of a given wire. So that is the first experiment. Second part of the experiment is find its specific resistance. After finding the resistance, you have to calculate the specific resistance. So this is your aim. Now materials required: meter bridge, battery, key, resistance, known resistance, unknown resistance, galvanometer, jockey, etc. Then the formula part is unknown resistance. This is what you are going to determine. Unknown resistance, X is equal to 100 minus L by L into R ohms. Resistivity formula rho is equals to X pi d square by 4L. So here if you see where capital D is the diameter of the wire in millimeter I have written. L is the length of the given wire in centimeter. X is the unknown distance what you are going to find out. Okay children. So this you have to write down in your record. So aim first you have to write, materials required and then formula. Now we are going to learn the circuit diagram, tabular column. Afterwards I will teach you the experiment how to take the reading. Now see this part. Here if you see circuit diagram, very carefully you have to listen that the whole part we call this as a meter bridge. So this is the meter bridge. So in this meter bridge if you see left side one gap is there, right side one gap is there. Then in left side gap you are going to connect a known resistance box you are going to connect. In right side gap the unknown resistance wire you are going to connect. Then in center one terminal is there. From the center terminal you are going to take a galvanometer. Here you are going to connect a galvanometer. Through the galvanometer you are connecting a jockey. Now from this point to this point if you see there is a 1 meter wire will be there. So 1 meter wire is there. Starting point is 0 centimeter to 100 centimeter will be there. So here if you see that this terminal to this terminal, again what you have to do, you have to connect a battery and then key. Okay. So again I am repeating, please listen very carefully. In meter bridge, two gaps are provided. In the left gap, you are connecting a known resistance. Known resistance means you are seeing the value 2 ohms, 5 ohms, 4 ohms, whatever the desired ohms you want, that is you can adjust in this resistance through the resistance box. Then here what we have given the wire, what you are going to determine the unknown resistance, that wire you have to fix it here with these two terminals. From the center terminal you are connecting a galvanometer and then a jockey. Okay. Now here if you see from A to B terminal, what you are going to do the connection, battery and the key. Now what you are going to do, how you have to do the experiment means, this circuit diagram, this meter bridge experiment is based on the Wheatstone bridge principle. What is the Wheatstone bridge principle? You studied in theory. P by Q is equals to R by S. 4 resistances will be there in Wheatstone bridge. And in theory part you studied. So if you know all the 3 resistances, the 4th resistance by substituting the formula we are going to calculate. So in the same way only you see that this part is one resistance and this part is the second resistance and this part A to J. Suppose if you consider this point as A, this terminal as A and this terminal as B. So A to J, suppose 60 centimeter is there, then this will be 100 minus 60, 40 centimeter is there. So this is the one resistance and this will be the second resistance and this part will behave as a third resistance and this part will also behave as a fourth resistance. Just like here, that's why we call this meter bridge principle is Wheatstone bridge ka principle hota hai. Okay. Now you see the tabular column. Understand the tabular column. So first one is serial number is there. Usually you have to take 5 readings. Then second part if you see known resistance. So from the known resistance means you know the value. So you have to fix the resistance 2 ohms, 4 ohms, 6 ohms, whatever the resistance you want to fix, you can fix. It is not the constant value, you can change, decide your value, okay? You can fix the value. Now balancing length is there. What is the balancing length means? By taking the jockey, after fixing 2 ohms from the resistance box, in this resistance box you have to fix first 2 ohms. Now you have to take the jockey, so first you press the jockey in A terminal, check the galvanometer deflection. If the galvanometer shows left side deflection, then take the jockey from and keep it in the B terminal. Now the galvanometer, see the galvanometer, it shows the right side deflection. That means when you press the jockey in the A terminal, it shows left side deflection. When you press the jockey in the B terminal, it shows the right side deflection. That means you should evaluate yourself, your connections are perfect. Okay, after knowing the connections are perfect, now you fix the 2 ohm resistance through the resistance box, you fix the 2 ohm. Now you have to find out the null deflection. This is called null deflection. How to find out null deflection means, take the jockey and press here. If you from A to B, you have to press the jockey to determine where the deflection of the galvanometer shows 0. That means no deflection should be there. It is called null deflection. So how to determine? Take the jockey, press here. If you see the deflection, then move the jockey. Again you are seeing the deflection, then move the jockey. So suppose imagine that in this place the galvanometer shows no deflection, 0 deflection. Then in that place you should calculate the distance from A to J. What is the distance? That's what I have done, 67 centimeter. And then what is this 67 centimeter? This distance AJ. Okay, this distance AJ. Now 100 minus L I put here now. So 100 minus 67, 33. Now just substitute the formula, x is equals to 100 minus L by L into R. This R value. So you will get this answers. Understand? So this is what the tabular column filling. I calculated all the values here for your purpose. Then you have to take, after finishing all the 2 ohms, then second part I will explain how you do. You change the known resistance value to 4 ohms. Then you take the reading. Again you change the null deflection, 74.5 will come. Again you change the known resistance value to 6 ohm. Again you find out the null deflection, it comes to 82 centimeter. Then again you fix the known resistance value to 8 ohms, then it comes to certain value. Then 10 ohms certain value. So after filling all the tabular column, take the value of X. So if you get 5 values, take the average, calculate the average. So that gives you 1.22 ohms resistance of the given wire. Okay. Now I will explain you how to do the connection based on the circuit diagram. Then how to take the reading, I will teach you there. Okay. Okay children, now we are going to learn the apparatus. So as I told you in the circuit diagram, see this is the meter bridge. In this meter bridge, if you see, this is called a left side gap. See here, left side gap. Now you see here, this is called a right side gap. Okay. Now you see this terminal I have taken as a terminal, and A to B terminal. If you see that 1 meter wire is there. So this is your meter bridge apparatus. Now what I connected in the left terminal, I connected from this 2 terminal, I connected a resistance box. So this in this resistance box you see here 1 ohm, 2 ohm, 2 ohm, 5 ohm, it is written, everything is there, values is written. That is why it is called known resistance is connected here. Okay. So this terminal to this terminal, and then this terminal to this terminal. So resistance box is connected here. Then center terminal, from the center terminal, see galvanometer connected. Then from the galvanometer, another terminal I am taking to, see here, I am taking this to, this is called jockey. So jockey is connected. Okay. Now right side gap, in the right side gap 2 terminals are there. In these 2 terminals you see, what is that? This is the exam, they will give you resistance coil. So in this resistance coil, you have to connect this terminal to this terminal, and then from here to here you have to connect. So this resistance coil only you are going to find out what is the resistance. What is the resistance of this coil you are going to find out. Okay children. Now again you see here, A terminal to B terminal is there in meter bridge. So A terminal I have connected, this is the positive terminal of the battery, and this is the negative terminal of the battery. So from the positive terminal of the battery I am taking to key, then from key I am taking to B terminal of the meter bridge. Now negative terminal I am taking to A terminal. So this is called complete circuit arrangement. So first thing I have to check that whether my connection is correct or not. For that what I told you, press the jockey in A terminal, see the deflection in the galvanometer. Then press the jockey in B terminal, check the deflection. Now you see here I am going to press here A terminal, see the deflection. See left side deflection. Okay. Now I am taking the jockey terminal to B terminal. Now see the deflection in the right terminal. See, right terminal deflection. Okay. Just switch on the battery. When you switch on the battery, here we switch on the battery. Now the current is flowing in the meter bridge after doing the connection. First thing is what you should know, whether the connection is perfect or not. That you should ensure. So for that, what you have to do, take the jockey and press at the A terminal, check the galvanometer deflection, and press at the B terminal, check the galvanometer deflection. If I press at the left side, then the galvanometer will show left side deflection. If I press on the right side, galvanometer will show right side deflection. If both side deflection is there, then the connections are perfect. Now see this jockey I am taking and pressing here, you can see the deflection here. Are you able to see the deflection? See left side deflection. Okay. Now taking the jockey, I am taking the jockey here and pressing here. Now you see the right side deflection. See right side deflection. So both left hand side, right hand side deflection is there. So the apparatus is perfectly connected. Okay. Here you can write down 2 ohms. First you can fix 2 ohms. Then you can fix to 4 ohms, 6 ohms, 8 ohms, 10 ohms. Okay. For 2 ohms, what you have to do? You have to take the jockey and press in the wire where the null deflection should be there. If null deflection comes means there you have to stop and note down the reading. Okay. Now you will see that. See this 2 ohms. What I am going to do? I am plucking this key. So if I take this, release this, now this is, I included 2 ohms means. So when I remove the 2 ohms key, then the meaning is I included 2 ohm. Okay, now I'm going to press here for deflection. I'm going to find out the null deflection. So see this, I'm pressing here, see the deflection. Deflection is there. Again I'm pressing here. Deflection is there. So at any one particular point, null deflection will be there. No deflection. There you have to stop. See this. Again deflection is there. Again deflection is there. Yeah. Now here you see right side deflection. Now you see, yes, left side deflect. Now see, this is the null deflection. Now the galvanometer is not moving. So this point, in this point you have to take the reading. Now you see here it is written 55.5. Okay. So that 55 point, now you switch off the battery. Write down here 55.5 is your balancing length. Understand, children? Now what we have to do, 4 ohm we have to fix. So see here. So already I have taken 2 ohm. Now I am taking one more key, releasing the key. That means 2 plus 2, 4 ohm is included. Okay. Again you switch on the battery and take the null deflection. How to find out the null deflection? I am keeping here. So here I am keeping left side deflection. Here I am touching left side deflection. Again deflection is there. Again deflection is there. Deflection is there. Yes, here you see that null deflection comes. Okay, so this point is null deflection. So what is the reading here? If you see 75 it comes. Hai na bachon? So see that galvanometer not moving. So that is the null deflection. So here I am taking 75. The reading is 75. So note down that. So for 4 ohms it comes 75. Okay. Now 6 ohm we have to fix. See this 6 ohm is not there. So what I am going to do? I am going to take the 5 ohms key and 1 ohm key. So 5 ohm key and 1 ohm key is totally it is 6 ohms. So 6 ohms I kept. Now I have to find out the null deflection. Again you see, take the switch on the battery. Then you place it here, seeing the deflection. Okay. Then place it here again, seeing the deflection. Place it here, seeing the deflection. Here somewhere null deflection comes. Okay. Now yes, here comes. So take the reading. There is a null deflection point. Yes, here again. So this is 76 point. Yes, 76. 76 comes. So note down here for 6 ohm you are getting 76. Okay. Now you have to fix 8 ohms. Na? 5 ohms, 7 ohms and 1 ohm. So totally 8 ohm is there. Okay, children. Now for 8 ohm you have to find out. Again you have to. Again what we have to do, take the jockey and place it here. See this, deflection is there, deflection is there, deflection is there. If you keep on the right hand side now, you will see the right side deflection. So where is the null deflection we have to find out. So see this, deflection is there, deflection is there. Now you see the galvanometer, see the galvanometer. Now you see, children, Yes, zero deflection has come, है ना? So for this zero deflection, see the value 80.5. Okay, so note down here, for 8 ohm it is 80.5. Now for 10 ohms we have to take. Okay, so this is a 10 ohm I released and I kept all this replaced right here. So now you see here 10 ohms I release, so that means for 10 ohm is included. Now I am going to find out the null deflection again. Take the jockey, press it here, press it here. Okay, see the deflection, yes, left side deflection, right side deflection. Now you have to find out the null deflection. Yes, now are you able to see? See that galvanometer shows zero deflection. Okay, so this place, what is the value now? It comes 88. 88 it comes. So that's all, children. So 88. Now we have to do the calculation. We will see the calculation here. So 100 minus L, na? 100 minus 55.5, that is 44.5. Then 100 minus 75 is 25. Here it is 24, and then here 100 minus 80.5, 19.5, 100 minus 88, 12. Okay, now see formula, 100 minus L by L into R. Okay, so this divided by this, 100 minus L by L, this divided by this into this. Okay, so 44.5 divided by 55.5 into 2, it comes 1.6. so the answer is 1.60. Okay, now here next value, 25 divided by 75, 0.33 into 4, so 1.33. Okay, now 24, next value 24 by 76 is equals to 0.31 into 6 something what's that? Okay, so I am doing 24 by 76. 24 by 76 is equals to into 6, 1.89. then you see here 19.5 divided by 80.5 is equals to into 8, 1.93. Here you see 12 by 88, 12 divided by 88 into 10. So 1.36. Okay, children. Now what you have to do? You have to add and you have to take the mean value. So mean value means what? You have to add all these things, na? Okay. And 1.6 plus 1.3 plus 1.89 or plus 1.93 plus 1.36. Okay, is equals to 8.08 divided by 5. So the value is 1.6. Mean value is 1.6 is the, so resistance of the given wire is 1.6 ohm. This is your answer. Understand, children? So in this way we have to do the resistance of a unknown wire. Now the same procedure, same experiment we have to continue for resistance in series. What we will do in series means we have to take this resistance and this resistance and we have to keep it in series like this. Okay, in series like this, and we have to do the connection. How I am doing the connection signal. Now see this, for resistance in series combination, what I am doing, I am keeping this here and this, okay. With this resistance I am connecting this resistance. So what I am doing here, gently you have to do the connections, just that's all, okay. Now this end I am connecting in this, okay. Now, oh sorry, this should be connected here. Now this wire should be connected with this. So same apparatus what I did, two resistance I connected in series, and this terminal is connected here and this terminal is connected here. So this is in series connection. Now we have to do the same reading we have to take. So what is the reading? See this known resistance, first one, then L is the balancing length, then 100 minus L you have to find out, then X value you have to find out.